Good morning, guys. Myself Prem, and I'm studying in class 12th. So today I'm gonna explain Maths 2A classes of 15th and 16th dates, which the college people have told me. So from 15th 4/24, 15th of April, they have given two sums and they explain the concepts. Okay. So first, let us discuss some sums. Find the real value of theta in order that 3 plus 2i sin theta divided by 1 minus 2i sin theta is so a real number, and b is purely imaginary number. So they have given this complex number, this expression, and they said to find the real values of theta. So solution, let us assume that z is equals to 3 plus 2i sin theta divided by 1 minus 2i sin theta. Okay, so it is in the form of expression. Now we need to convert into complex number form. So z is equals to, we know that in denominator they should know not present of imaginary number. So 3 plus 2, we need to rationalize. 3 plus 2i sin theta divided by 1 minus 2i sin theta into 1 plus 2i sin theta and 1 plus 2i sin theta. It is in the form of a minus b into a plus b, which is 3 plus 2i sin theta into 1 plus 2i sin theta. It is in the form of a minus b and a plus b. So which is a square is 1 and 2i sin square is nothing but 4i square sin square theta. So we know that I square is equals to minus 1. I square is equals to minus 1. Then by simplification we can write 3 plus 6i sin theta plus 2i sin theta plus 4 sin 4i square sin square theta. So sin theta, 4i sin theta, so sin square theta, sorry. Okay, then 1 plus 4 minus into minus is plus, 1 plus 4 sin square theta. Okay, 1 plus 4 sin square theta. Now let's continue. Then we get the value 3 minus 4 sin square theta plus I plus 8i sin theta divided by 1 plus 4 sin square theta. Okay, taking real numbers apart from complex numbers, I mean imaginary numbers, 4 sin square theta divided by 1 plus 4 sin square theta plus I take common and 8 sin theta divided by 1 plus 4 sin square theta. Okay, so we have written this expression into complex number form. Now we need to, first case we need to find if it is real. If it is real, then imaginary of z is equals to 0, that is 8 sin theta divided by 1 plus 4 sin square theta is equals to 0. Cross multiplication, it forms 8 sin theta is equals to 0. Taking 8 to RHS, then sin theta is equals to 0. And the given, we can write given solution as theta is equals to n pi or n belongs to z. Okay, now if ab, sorry, now second condition, if z is purely imaginary, then real number of z is equals to 0. 3 minus 4 sine square theta is equals to 0 divided by 1 plus 4 sine square theta. Cross multiplication, then we get 3 minus 4 sine square theta is equals to 0. Sending minus 4 sine square theta to RHS is equals to plus 4 sine square theta. Sending 4 to LHS, sine square theta is equals to 3 by 4. Sending root to RHS, sine theta is equals to root 3 by 2. Now squaring on both sides, then sine square theta is equals to root 3 by 2 whole square, which is sine square theta, root 3 by 2 is nothing but sine pi by 3. So it's nothing but sine square pi by 3. Sine square will get cancelled and theta is equals to pi by 3. Now general solution is nothing but, for sine theta formula is theta is equals to n pi plus or minus alpha, where n belongs to z. Here alpha is nothing but pi by 3. Theta is equals to n pi minus pi by 3, n belongs to z. This is general solution. That's it. We found the general solution, theta values, real values of theta. Now let us discuss another question. For second question, find the real values of x and y if x minus 1 divided by 3 plus I plus y minus 1 divided by 3 minus I is equals to I. Okay, they said to find x and y values. Solution, take LCM. It is in the form of a plus b into a minus b. Then I'm writing directly, then it forms 9 minus I square into x minus 1 into 3 minus I plus y minus 1 into 3 plus I is equals to I. Sending 9 minus I square to RHS, we know that I square is equals to minus 1. X, by simplification we can write 3x minus 3 minus ix plus I plus 3y plus iy minus 3 minus 1, sorry, minus I is equals to I into 9. Minus into minus is nothing but plus 1. Then the overall answer is, taking a real part aside and imaginary part to one side, then 3 plus 3y minus 6 plus, taking I common, minus x plus y is equals to 10i. Okay, we can write this 10i as 0 plus 10i. Now comparing both sides, compare both sides, real to real number and imaginary to imaginary number. 3x plus 3y minus 6 is equals to 0 and minus x plus y is equals to 10. Okay, taking 3 as common, then x plus y minus 2 is equals to 0, x plus y is equals to 2. This is first equation, this is second equation. Now subtracting these two equations, x plus y is equals to 2 and minus x plus y is equals to 10. Minus x plus x will cancel, then 2y is equals to 12, 2 ones are 2, 12, 2 ones are 2 6 are, then y is equals to 6. Now substitute y value in equation 1, that is x plus y is equals to 2, x plus 6 is equals to 2, x is equals to minus 4. Therefore the values of x and y are, x value is minus 4 and y is plus 6. Okay. Now let us discuss modulus of a complex number. Modulus of a complex number. The modulus of a complex number is nothing but the absolute value of a complex number is defined to be the non-negative real numbers, which is root over x square plus y square. Root over x square plus y square is called modulus. Is called modulus. It's called modulus. Now which is also it is denoted by mod of z, and its formula is mod z is equals to x plus iy, mod of x plus iy, or root over x square plus y square. Okay. Now modulus of complex number properties. Okay, first property, mod of z1 into z2 is equals to mod of z1 into mod of z2. Second property is mod of z1 is equals to conjugate mod of conjugate z1, conjugate of z. Next, third property is z1 into conjugate of z is equals to mod of z1 square. Fourth property is mod of z1 by z2 is equals to mod of z1 by mod of z2. Okay. Now let us discuss about amplitude of a complex number. So let me draw a diagram. This is x axis, y axis. This is a point of a complex number. This is y, x square plus y square. Okay. So the amplitude of a complex number is nothing but a non-zero complex number which belongs to a real number, satisfying the equations sin theta is equals to, sin theta is nothing but opposite by hypotenuse, y by root over x square plus y square, and cos theta is equals to x by adjacent by hypotenuse square plus y square, is called the amplitude of a complex number. Okay, its principal amplitude or theta lies between, theta belongs to open interval of minus pi to close interval of pi. Okay. Now the principal amplitudes of different types of complex numbers in different quadrants. Let us discuss about that. Let's draw a quadrants, 4 quadrants: q1, q2, q3, q4. q1, q2, q3, q4 are nothing but quadrants, and in this y, x, y dash, x dash, and is in this first quadrant x is greater than 0 and y is greater than 0, then theta formula will be tan inverse mod of y by x. Now in second quadrant x is less than 0, y is greater than 0, then theta formula will be pi minus tan inverse mod of y by x. In third quadrant, x is less than 0, y is also less than 0. Then theta formula is minus pi plus tan inverse mod of y by x. In fourth quadrant, x is greater than 0, y is less than 0. Then theta formula is equals to minus tan inverse mod of y by x. Okay, these are the amplitudes of different quadrants. Now let us discuss about a modulus amplitude form or polar form. Modulus amplitude form or polar form. Okay, it is nothing but if a complex number z is equals to I plus y, x plus y, z is equals to x plus iy be a complex number, then r of cos theta plus I sin theta is called a modulus, and amplitude is r is equals to root over a square plus y square, x square plus y square. Okay, which is nothing but x plus iy is equals to r of cos theta plus I sin theta. Okay, this is modulus amplitude form. That's it, guys. This is 15th of April class, and I'm gonna explain 16th of April class in next video. Thank you. If anyone has doubt, please comment.